My name is Jisong Chin and I am a master's student at the RWTH University here in Aachen. I'm doing my master's thesis in data and process science by the chair of heads it's called, and it's held by Professor van der Aals. And I'm today talking about real-time insights with animated visualization with examples from process mining. You are probably wondering why process mining, and in a few minutes you will realize that some results from process mining heavily depend on animated visualization. Yeah, it's working. So, who of you heard something about process mining? Okay, more people than I thought. Right, this talk is about visualization, so I do not want to go too in depth about process mining, but to give you an overview of process mining. Because of digitalization and Industry 4.0 and big data adoption and kind of stuff like that, a lot of companies begin to collect more and more data. And they already used to have a group in their companies to deal with business questions via data science teams or process science teams. Usually they are called business analytics group or business strategic groups or something like that. Using those techniques from data science or process science, there are a lot of algorithms, clustering algorithms, classification algorithms, regressions, and more to really gain insights from the collected data. But this is already a very good foundation to answer a lot of strategic questions. But those answers or those solutions from data science or process science, they usually give you a very static view on those data. And an obvious development of this would be the process mining approach, where you try to combine the business questions from both fields, meaning from data science and process science, and not only reveal the static view of the data, but also try to answer a dynamic behavior of your data. As you can imagine, processes are by nature a very dynamic collection of data, because your process is defined by process steps over time. And with the current algorithms from data science or machine learning, it was not easy to solve those dynamic behavior questions. This is an example of a process log. A very typical characteristic of the data is that we always have these timestamps, because we want to order those data by their timestamps to extract from those data the time-dependent information. How does it work? We have a log, and by a fancy wizard with some process mining algorithms, we extract and process model. Usually, as a result of those algorithms, we will get a workflow net, which is very commonly used in process science, or also Petri nets, which is a very good modeling model. Sounds weird, but it's a model which is often used by mathematicians and computer scientists and also system engineers. There is a subfield in process mining which is called replay. And as you can already assume from the name, in the replay we have on the one hand side the model, on the other hand side we have the log, and we try to visualize this every entry of the log on the model. What's the real meaning of it, you will see later in my examples. The typical questions, what you want, business questions, what you want to answer using process mining techniques are like finding bottlenecks in your processes, or highways, or some process steps which were not defined by the original business owner, but are used by the workers because this is faster. and to answer the questions like if it's needed to redesign some processes. Now we will come to the examples. This is the first example what I prepared, and here this is how the animated visualization works in process mining. As already mentioned before, this is a result of the process model extraction, and those small circles represent a process which can be flowed through this model from beginning to end. The first animated visualization method what I want to highlight here is the coloring. We now already have seen a lot of examples, coloring examples from the talks before, but here again, using different coloring methods, it's possible to emphasize a specific process step. You also can realize, you can see those small colorings and counters. We have blue counters, we have green counters and red counters. And using these different colors, we represent different acceptance states of the process steps. The green one represents starting processes. The blue ones represent through flowing processes, and the red ones represent finishing processes. Using only this visualization and without doing any further in-depth analysis on the data, you can, for example, find out deviations. Usually businesses define a process model, which means that the user already know in which process steps it's allowed to be finished. When you look at, for example, this one, you have here, I think this is four times a process has been finished in this step. But it was predefined by the business owner that every process should be finished at the last one. This means, in some cases of the processes, the worker did not work properly and finished a job which was not really finished. And those insights can really be found out via the animated visualization. The last method what I would like to highlight in this example is the use of speed. When you look at those circles, you can see sometimes that the circle runs faster and others run slower. Using these different speeds of the circles of the process of each process steps, you can show the speed of each. You can find the duration characteristics of each process. Faster running throughs stand for a very fast process step, and slower flowing circles represent a very long duration of a process. This is the second example. This is also again a process model which was extracted from another process mining tool. And when you compare this representation from the representation from before, you realize that there are a lot of similarities, but here a lot of in-depth information has been extracted away for the user. For example, there are no counters or there are no numbers between them. The user should really focus on the flow of each process. Here again you have this highlighting methods, you have this coloring methods where going through process steps are highlighted or colored in different colors. And again here, each process step is visualized using those circles. But here, in comparison to before, here's another method which I call different shapes or different sizes of the shapes. Meaning, the circles have different circle sizes, and here in this case this represents the frequency of a process. Bigger circle sizes represent more frequent processes, and smaller sizes represent not so frequent processes. In this representation, again, we have the method of using variety in speeds. Here, sometimes you have very slow processes, and here, for example, you have very fast one, which again represent the duration of each process. This is my third example. This is again another process model, and what I wanted to highlight here in this example are the different colors of the circles. I tried to zoom in as much as possible, but the tool did not allow it to zoom higher. But here you can see that the circles have now different colors. And here in the setting, this resolution is not so good, but you can set what those different colors should represent. Here, in this case, it represents, again, the frequency of each trace, meaning darker colors are more frequent in the process log, and lighter colors represent less frequent logs. But it's possible to change the configuration such that those darker colors, for example, should represent more longer duration of the processes, and lighter ones more faster processes. This is my last example. When you analyze process data, then it's very common that you have a lot of variation in your models, meaning you do not want to present every possible variation of your process at once, because then the user wouldn't understand anything. But first, you try to build an overall model which represents the majority of your process data, and then let the user to select how many variations he or she wants to see. Here in this example, using those settings, you can choose that you want to have more variation in your data or less variation. This would be the majority of your processes, and in real time, it's possible to have a more variety in your representation. And that concludes my talk. We have seen some methods from animated visualization, like highlighting, real-time counting, coloring, using different speeds and different shape sizes and real-time deviations. And using only those methods in the visualization, it was possible to see or reveal more information about performance insights and unknown behavior, bottlenecks, and deviation analysis. And there were no in-depth data analysis needed to find out those informations. So I kept it short and crispy, and I hope that you could gain some information about it, which would also support your needs in your animated visualizations. Thank you.
So again, do we have questions towards this real-time animation of information? Can we start here?
Yeah, thank you for the talk. It was really nice and interesting. And I have a question regarding how well tested are these methods, or regarding their how the information is really brought to the user. You had something on your last slide, I think. Are these really qualitative studies or quantitative studies regarding these topics?
You just come with me.
Yeah, well, there were no real studies about the solutions, but currently many process mining startups are coming from everywhere. And they start, or when you compare them, then they start to adopt the similar animations. And there are also a lot of consulting companies who work with other companies on those problems. And all the customers want this type of animation, which then leads indirectly to this solution, to the result that those visualization techniques, methods are really relevant to reveal those information what I mentioned here.
Okay, there was another question as well, I guess. Somewhere here.
Yeah, very interesting talk. Thank you so much for it. I'm wondering where you see the limits, because sometimes it's getting really, really complex, and there are like so many entities and so many relationships between these items, and you have like several flows, and like where do you see the limits, and what do you think how we can deal with them?
Yes, that's true. For this talk, I chose a very small log where the deviations were very limited. But in reality, you cannot visualize one process with one model. And this is really a problem. And there are a lot of techniques to filter those logs by frequency, by some statistical analysis, to create only a subset of the model, because otherwise those models wouldn't reveal any information about the real processes. The companies, how I say without getting into trouble, it was found out that there are predefined processes usually in businesses, but and many people do not really follow those process steps, but they have their own way of solving the problems. And this is really represented by real life log data. And when you just consider or just push those models on it, then you cannot solve any business questions. So again, filtering is needed to only keep, for example, the majority of the logs, to create a more representative process model. There are also other research directions to limit those limitations, but I think before going to in-depth discussion, we can also talk later.
So maybe one more question. And the others, please go to our collection.
Okay, yeah, thank you very much. Maybe that goes into the same direction as the question before, but do you have any papers or any investigation on the benefits of the real-time visualization? Because the way I see it, especially with the questions that you stated on the slide, I don't see any benefits between the dynamic visualization and static visualizations on the same data. So, do you have any insights on that?
Thank you very much. That was my question also.
Again, these were some results from really applying those methods in real business questions. And of course, this is very domain specific, and it depends on the problem what you want to solve. But there are definitely some evidences which reveals the benefits of this real-time animation or the animated visualization of those data. But I can give you later a reference to it, such that we can then begin a discussion about that.